Hello friends, in this video I'm just going to go over compound probability. I'm just going to run through different ways to do it, a couple different ways. I'll share what my preferred method is. But yeah, so remember, dropping stuff, that compound probability is the probability of two or more events. So what's the probability of getting 2 ones when you roll 2 dice? Or if you're at an ice cream store and you have flavors to choose from, toppings, and then you have a type of cone to choose from. So those are 3 different things: flavor, cone, topping, that you can choose from. That would be compound probability. Cool. So let's get started. So a common one we see is we're going to use an area model, or if you've done them in science, they're also called Punnett squares if you do them with genetics and science. So this is one you would use for 2 events. So you're rolling 2 dice. What's the probability that both of them are odd? So let's start with our first step. We're going to list all the possible outcomes for dice 1, or die 1, on the left. So I'm going to say die 1. Okay. And when I roll a die, it can land on numbers 1 through 6. So I'm going to label 1, 2, 3, 4, 5, 6. Okay. Then our step 2, list possible outcomes for the second thing. So die 2. And it has the same possible outcomes: 1, 2, 3, 4, 5, or 6. Okay, then my step 3, I'm going to make this sample space, which is the total number of combinations. I'm going to start this top left square, work my way from left to right, and then go down and do the same thing. So starting in this square, the things that can happen is I can roll a 1 on the first die and a 1 on the second die. Then moving to the right, I can roll a 1 on the first die and a 2 on the second one. I can roll a 1 on the first die and a 3 on the second one, 1 and 4, 1 and 5, 1 and 6. Okay, so go ahead, take a second, draw this with me, and start filling it out. And I will go through and label the rest of them. Okay, so take a second. I'm going to pause the video and just finish the rest of it while you do that yourself. Okay, so here is my finished area model. So let me just pick a random one. How about this one? Okay, so that square that's in green means that from the first die, I rolled a 5, and the second one, I rolled a 4. It kind of works like a multiplication chart. Okay, so I want to know the probability that they are both odd. So remember that the probability, then odd and odd. Okay, so I'm going to go through and highlight all of the ones where both outcomes are odd numbers. So 1 and 1 are both odd, 1 and 3, 1 and 5. Okay, for the second row, one of those dice is always going to be a 2, so I know it's not going to be any of those. Then here I have 3 and 1, 3 and 3, 3 and 5. Same thing for the fourth row. Since 4 is even, none of those are going to be odd. So then I have 5 and 1, 5 and 3, 5 and 5. Okay. And then 6 is not going to work since 6 is even. So let's count how many that is. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll write it as a fraction. Our probability is the number of desired outcomes, so 9 of them had both numbers odd, out of the total number of squares, total number of possibilities. I can just multiply. There's 6 on this side times 6 on the top. There's 36 total squares. I need to simplify my fraction. I can divide these both by 9, which gives me 1/4. As a decimal, I'm just going to take 1 divided by 4, which is 0.25. And as a percent, I'm going to take that times 100 and get 25%. So these are all ways to show a probability. Right, so a tree diagram is most helpful if there's 3 or more. You can use it if it's 2 or more options, but I usually use it just for 3 or more. Because we have a menu board at a sandwich shop, and it has 1, 2, 3 categories. Okay? So we want to know what the probability of choosing ham, cheddar, and white bread. So I'm going to go through with the first category of bread, and I'm going to list the possible outcomes. You can either have white or wheat. And notice that since they both start with W, I added that H next to wheat to differentiate between them. Okay, those are all my choices from the first column. Then I have my choices for meat options on my sandwich, and I need to list those off of each type of bread. So I can choose white and then ham, or I could choose white bread and bologna. I could choose wheat and ham, or wheat and bologna. Done. Then, off of each of those, I need to list the outcomes for cheese. I have cheddar, American, and mozzarella. So I could choose ham and cheddar, American, mozzarella, bologna, cheddar, American, mozzarella. Then I could have wheat bread and ham with cheddar, American, or mozzarella. Wheat bread with bologna and cheddar, American, or mozzarella. Okay. So I'm going to list the sample space, which is just a list of the combinations. So starting here, I have white bread, then ham, then cheddar. So white bread, ham, cheddar. Then I could have white bread, ham, and American cheese. So white bread, ham, American. Could have white bread, ham, and mozzarella. So white, ham, mozzarella. Okay, so go through, try to make the next choice starting with white bread and bologna, and then list the combinations, okay? Okay, so you should now have all the combinations for the first part, the first branch for white bread. Now I'm going to just do the same thing but with wheat. So take a second and try starting that on your own to make the combinations. Okay, so I've made my sample space now. Now we're going to find the probability. And we wanted to find the probability of white, ham, and cheddar. So I'm going to see how many have that combination of WHC. There's only one out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's a 1 in 12 chance, or as a decimal, I'm going to take 1 divided by 12, and then times 100 gives me my percent. All right, so there is a somewhat faster way to do some of these. If you don't feel comfortable with multiplying fractions, that's fine, just use the other methods. But here I made a little formula. So if I want to have the probability of two events, I take the probability of the first thing times the probability of the second thing. Okay? So right here it says, you draw a card from a deck, then replace it. What is the probability you draw a 4, then a jack? And I just made a side note, a deck has 52 cards total, 4 of each number and 4 of each suit. So 4 of each number or face card, and then the suits are like the hearts, the diamonds, the spades, and the clubs. Okay? So we want to know the probability of a 4, then a jack, which to do the multiplication method, we're going to find the probability of a 4 times the probability of a jack. Okay? There's 4 of each number. So there's 4 4s out of 52 cards times a jack is a face card, so there's 4 of those. 4 out of 52 cards total. Then I'm just going to do top times top is 16 divided by 52 times 52. It's 2,704. I'm going to try dividing both of those by 4. Those are both even, so I can divide by 2. Let's try dividing by 4 and see if that works. Okay, when I divide by 4, I get 1 over 169. Then I'm going to do that as a decimal. 1 divided by 169 is 0.006, which is 0.6%. So that last one said we replace the card, but what happens if I take something from a bag or a deck and I don't replace it? Okay. So a bag of marbles has 3 red, 5 blue, 2 green, and 8 yellow. You draw one and do not replace it. What's the probability of red then blue? Okay, so order matters here. So probability of red then blue. When we don't replace it, that means that we have to subtract 1 from the total. So my probability of red, well, there's 3 red, and I am going to find the total number of marbles by adding them together. So 3 plus 5 plus 2 plus 8 is 18. Actually, I'm going to put that down here. And then we're going to multiply it by the probability of blue. Okay, so since I drew a red one, there's still 5 blue ones left in the bag. But since I took that one out and I didn't put it back, there's only 17 left in the bag. So I'm going to do 3 times 5, which is 15. Then 18 times 17 is 306, which is divisible by 3, which gives me 5 out of 102. And 102 will not be evenly divisible by 5, so I'm going to stop there. Then 5 divided by 102 is 0.049, which is 4.9%. So either as a fraction, a decimal, or a percent, that's your probability of pulling out a red, you don't put it back, and then pulling a blue. So let's try the multiplication method if we have a choice of 3. So we have that same menu board from before. We want to know the probability of ham, cheddar on white. So the probability of ham, we'll start with the bread. White bread, ham, and then cheddar. So this is going to break down to the probability of white bread times the probability of choosing ham times the probability of choosing cheddar. Okay, well, white bread is 1 out of 2 types of bread times ham is 1 out of 2 types of meat times cheddar is 1 out of 3 types of cheese. So I'm just going to do 1 times 1 times 1, just 1, over 2 times 2 times 3, which is 12. Okay, and I could do 1 divided by 12. So that's 0.083, the 3 repeats, times 100 to make it a percent is 8.3 repeating percent. Okay? What if I wanted to find the probability, oops, a little too small there, of ham or mozzarella? I'm going to take the probability of ham times the probability of mozzarella. 1 choice is ham out of 2 meat choices, times mozzarella is 1 out of 3 meat choices. 1 times 1 is 1, divided by 2 times 3 is 6. 1 divided by 6 is 0.166 repeating, times 100 to make it a percent is 16.6 repeating percent. So the fraction, decimal, percent are all just a different representation of the same value, just in different forms. So I hope this refresher of compound probability was helpful. On the YouTube page, there are more broken down videos, so just tree diagrams, just area models. Okay, this is just a quick refresher. As always, let me know if you have any questions. Have a mathematical day.